ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. So today I want to talk about a small theory regarding arithmetic progression and arithmetic series here. In your 10th and in your first PUC mathematics classes, you have learned this concept there. You already know that arithmetic progression that is AP has general formula or has general expression here. That is, if A is the first term of the arrangement, that is arithmetic progression. If A plus D is the second term, then there is a difference of D between the second term and the first term here. In third term will be taken as A plus 2D, fourth term will be A plus 3D, fifth term will be A plus 4D, so on. Right? The nth term will be given by, you already know that. So nth term of the AP is given by first term plus n minus 1 times difference here. Suppose if I want to get the second term here, what can I do here? I have to add the difference to the first term here. I have to add one time difference to the first term, then I will get the second term here. In the same way, I have to add two times difference to the first term, then I will get the third term. So if there is a difference of D between the successive terms here, then I have to add two difference or two times difference to the first term, then I will get the third term here. So one time plus one more time here. If I add two difference or two times difference to the first term, then I get the third term here. In the same way, if I want to get the fourth term here, I have to add three times difference here. So one time, second time, and three times here. One time, two times, three times. So you have to add the 3D to the first term to get the fourth term here. So to get fourth term, you have to add three times of difference to the first term here. In the similar way, to get the nth term, you have to add n minus 1 times difference to the first term. This is the general form of the or general term of the AP, right? This is the general term of AP. If you look at this formula, or if you look at this nth term here carefully, you can say A plus, you can multiply D to this n as well as to 1 here. So D into n is n times D here. So D into 1 is D. Identify it. You have A plus n D minus D. I want to take it as n times D plus A minus D. Suppose we have arranged this thing into different form here. Nd, that is, and plus A minus D plus A minus D. I can take it as two terms here. We have one term, we have another term here. I can take this as two terms here. Sum of two terms here, two factors here. Here in this right side, we have a component that is A minus D. We have another component Nd. Right? If you don't know which term you are talking about, here we don't know what is the n term here. Which term we want here? We may want 100 term, we may want 50th term, we may want 101th term, right? Here n will be unknown thing here. As long as you don't know which term you want there, it will be unknown thing here. Isn't it so? We can say here, so this n in the right form, in the right side of the expression here, this n is unknown thing here. As long as you don't know which term you are talking about, then n will become variable here. N becomes variable. It can take 1 for the first term, it can take 2 for the second term of the AP, it can take 9 for the 9th term of the AP. For 10th term, n will be 10th year, 10 year. For 12th term, it will be 12 year. For 100th term, it will be 100 year. So n value may vary depending on which term you are talking about. Isn't it so? Therefore, n can be taken as variable here. If you know the first term of the arrangement or the AP and difference between the two successive terms there, then you know two things A and D. These are known values here. A and D becomes known values here. But if you don't know which term you are talking about the arrangement there, then n becomes unknown thing here. That is variable here. That is so. If n is the unknown and D is a known thing here, then I can say a variable times D is a known number here. I can take it as a constant, a known number, because difference between the two successive terms will always be a constant one here. Plus a is first term here, which is again if you know the first number, then it becomes a constant value. If you know it, it becomes a constant value here. And it is a constant minus a constant. Constant minus a constant. Isn't it so? A constant minus constant is not zero. A some value minus another value will be one more value here. So I can take it as one more constant. One more constant here. So we have variable to the power 1 here. We have variable n to the power 1 here, and we have some constant multiplied to the variable. We can call it as coefficient. We can also call it as coefficient here. So this can be called as coefficient. A constant which is multiplied to unknown variable can be called as coefficient here. So coefficient. Right? We can say we have a coefficient b for the variable n whose order or degree is 1 here, whose power is 1 here, and it is added with another constant. So this can be compared to the general form of linear polynomial. You already know the form of linear polynomial, right? You know the general form of linear polynomial. What is linear polynomial? What is the general form of linear polynomial? You can say ax plus b, where a and b are constant values, the real values, and x is the variable, unknown value that is variable. So whose power is 1, it is having a coefficient a here added to some constant b here. This is a general form of linear polynomial. So linear polynomials general form, you already know it is ax plus b, linear polynomials. So general form is given by ax plus b. Then our nth term, our general term, our nth term of the AP, which is given by a plus n minus 1 into d, nothing but nd plus a minus d, nothing but nd plus a minus d is how? It is looking how here? It is just like a linear polynomial, having variable n to the power 1, having coefficient to d for the variable n, and some constant of a minus d. Isn't it so? Therefore, nth term of an AP, I can say nth term of an AP, that is an. Symbolically, we can write it as an. Nth term of an AP is a linear polynomial. Is a linear polynomial. If you know the values of first term and the difference, and if you don't know what term you are talking about, which term you are talking about, then expression becomes, in that specific case, the expression becomes linear polynomial. For example, we have an AP 2, 4, 6, 8 dash dash dash. Right? If I want to get the 50th term, then I know the value of n here. If I want to get the 50th term, n becomes 50 here. This time n is going to be a value, not a variable here. If you want to get the 100th term here, n becomes 100. So if you don't know which term you are talking about here, or if you don't know what term you want here, then that becomes variable here. So I can say nth term is given by the formula a plus n minus 1 into d. Can you look there? So n term is given by, what is the here first term? 2 plus, I don't know what term I want to take here, or what term I want to talk about here. It would be n term. ಅದೇಂದ್ರೇನ n term ಅಂತ ಕರೆಯೋದು. ಯಾವ term ಬೇಕಂತ ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಸದ್ಯಕ್ಕೆ. I may wish to take any term there. This is 2 here. So 2 into n minus 2 1 is 2 here. So 2 and 2 cancels here, left with 2n here. Look at here, as n is a variable of power 1, it has coefficient 2 here with constant 0. So this is of the form linear polynomial. Therefore, nth term of any AP is always linear polynomial. If you don't know which term you are talking about, or the point is